What we're going to look at today is this bridge made of coins. Now, the towers on either side of the bridge are crucial, and we've tested this, to the bridge's structural integrity. And we've got a couple of theories as to how this bridge is going to fail if we remove those towers. So I'll explain them and then we'll actually test it to failure and try and find out which one is correct. So our first theory is, you can see the bridge isn't a complete straight beam, there's a bit of a camber to it, and possibly it could be behaving like an arch. That is purely in compression. So there'll be lines of thrust coming down and applying thrust in some combination of vertical and horizontal reaction outside of the piers. And these towers will be providing a vertical reaction which will keep this aggregate line of thrust in the line of the piers. So if we remove it, what could happen is that the piers themselves will fail and start to move outwards. This part of the structure here will move outwards and the middle of the bridge will just collapse. So that's one theory. The second possibility is that this bridge is behaving pretty much like a beam, because the connections between these two coins, although there's no actual adhesive connection, could possibly provide some tensile resistance. So there may be a small amount of tension in the bottom section, a neutral axis quite close to the top of the bridge, and then compression in the very top. And if this bridge goes past its capacity, it will form a plastic hinge because of the distribution. There's going to be a maximum bending moment in the middle, right at mid-span. So we'd expect there to be a plastic hinge formed at mid-span, which would be normally a failure in a simply supported beam. But because we've got these towers, they could be basically providing fixity at either end. So that single plastic hinge isn't enough to cause failure. But when we remove it, you may see two other plastic hinges forming and the bridge bending and collapsing in the middle. So let's test this and find out. We've only got one chance, but if we start by removing coins from either side, either there's going to be a smaller and smaller vertical component of force, or there's going to be less and less rigidity in the connections at the end. At the moment it seems to be holding up fairly well. We have designed this bridge too well. It seems to be starting to go. Oof. So you saw some movement there. And in fact, I think what we've seen, we've got a plastic hinge forming in the middle by the looks of it, because we're starting to see some deflection at midspan. There's not much going on the piers on either side, but it hasn't failed yet. So what we can do is add a bit more weight to this structure. And I don't know, post your comments at the end, but I think that was definitely a case of plastic hinges forming at the end as a result of that plastic hinge in the middle.
Well, I disagree with the beam theory. I think the structure, the penny structure, failed as an arch, because as we can see, as it failed, we could clearly see the piers moving outwards, and I just think that's the thrust of the arch being released and, horizontally pushing the piers outwards.
Well, it goes to show analysing failure mechanism structures is not an easy task, and yeah, like I said, we'd be like to hear anything you think.